This is the video on measurement. So in these videos, there will be two codes. One will be a written code that will pop up on the screen. The other code will be a verbal code said by myself. Each code will be 3 numbers. You will need all the codes in order to move on with the homework assignment. So when you're looking at these slides and deciding on what to take notes, write what is in green. That is the important things that should be on there. The rest is a good additional information, but not necessary. So this is the written code for this week. I would recommend writing this down somewhere. All right, so let's answer this question. What is a second? So if we look at the English system, right, where the standard measurement for everything in America, you can see you've got inches, you've got feet, you've got yard, miles, and you've got nautical miles, and you've got palms, a cubit, a grade, step, rope, a lot of different ones, and you can see they're multiplied by a lot of different things. Now, the English system was an honest first attempt to standardize the system. Without fast communication, it was very hard to standardize measurements. So common objects were used. An inch was 3 barley corns put together. Yard was the distance between the nose and the tip of your fingers. Notice how 12 barley corn inches does not add up to what we think of as a foot. So there are some drawbacks to the system. So if we were building a house, we would need to make and we had two people, one person building the first floor, another person building the second floor, and they use their yard from the tip of the nose, tip of the finger. There's no guarantee that that is the same length. But we could make this work out by using only one person to measure everything. Then it would work out, and this worked out for hundreds of years. But if you're selling something like by weight to maybe another village or another town over, there's no guarantee that there's going to be the same standardized unit of measurement. So this is an easy question that gets a little tricky. What is the definition of 1 second? So you can't just say that one tick on a clock, because then I'm going to ask you, how would you determine how long an interval of the tick represents? So the point of this assignment is that you can know the name of a bird in all the languages, but when you're finished, you'll know absolutely nothing whatsoever about the bird. So let's look at the bird, see what it's doing. That's what counts. I learned very early the difference between knowing the name of something and knowing something. So the idea behind this is that a second, you probably say, well, there's 60 seconds in a minute, right? Well, then I would ask you, well, what's a minute? And then you'd say, well, there's 60 seconds in an hour. Well, okay, well, what's an hour? Well, then you'd say, well, there's 24 hours in a day. And you look at that and, well, what's a day? A day is the time that it takes the Earth to rotate about its axis. And that's the same for everybody on the planet Earth. So that is a standard I use in measure, something that's the same for everybody. But now the second in 1967 was defined as the duration of 9,192,631,770 oscillations of the cesium-133 atom. That electron in the valence electron, it oscillates, it switches energy states, and we can measure that many, a certain amount of times, we say that's a second. Now, the benefits to this is that the cesium atoms all over the universe will oscillate the same way. It's based on something universal. So why do we use the metric system in science? The metric system is used in science for two reasons. Number one, it is universal. Everything is defined as constants of the universe. It's also base 10, so it's really easy to use. You can see that metric conversion chart down at the bottom. Very easy to convert within the metric system. So let's just take a look at how it is. So to convert from one unit to another within the metric system usually means moving the decimal point. If you can remember what the prefixes mean, you can convert within the metric system relatively easily by simply multiplying or dividing the number by the value of that prefix. So the measurements that we will be concerned with in this class will be length, mass, time, and force. So let's get some practice. So let's take a look at what is 1.5 kilograms converted to grams. So I'm looking at kilograms. So that's the one all the way over here at the left. Kilo, 1,000 grams. Converted to grams. I need to move the decimal to the right to get to the basic unit. Now I need to move it 1, 2, 3. Because it's just like playing a board game. You don't count the space that you're on. You just move 1, 2, 3. So I move it to the left, to the right 3 times, and I get 150 grams. Let's take a look at another one. What is 20 centimeters converted to millimeters? So now I've got centi, meaning 100, right? And milli, meaning 1,000. So I've got centimeters, right? And I move the decimal to the right one spot, and I get 20 centimeters is 200 millimeters. Now, what is 1,000 milliliters converted to liters? So this one I need to go the other direction. So I'm starting with milli, and I'm moving to the left 1, 2, 3 spots, and I get 1 liter. So when we're looking at the metric system, we need to know length. Now, the basic unit of length in the metric system is the meter. A meter is about the width of a doorway. Now, millimeters, 1/1000th of a meter is about the thickness of a dime. A centimeter is about the width of a large paper clip. A kilometer is about 6 city blocks, 10 football fields. So these are different units that you need to know to convert. It's just easier to visualize when you compare them to something. So at this time, I'll go ahead and give you that verbal code. The verbal code is 814. I say that again, the verbal code is 814. So when we're measuring mass in the metric system, mass is the amount of matter in an object. Let's see, the base unit of mass is the gram. 1 gram is about the mass of a dime. Now, in physics, in physics, most of the equations require kilograms. So kilogram is about the mass of a filled water bottle. It's about 2.5 pounds or so. So you fill a bottle up, and that is going to be about the mass of 1 kilogram. All right, and volume. Volume is the amount of space an object takes up, and the base unit of volume is the liter. So so this is an assignment that we did, an activity where we got some practice converting within the metric system. So just as a final thought, remember there is too much unknown in the universe to take a break from learning. Get out there and question everything.